Domain and range of absolute value functions. So first, let's review. Domain is the all possible x values. So this reads your graph from left to right. And range is all possible y values. So this will read your graph from bottom to top. So if we look at our first example, we have the absolute value parent function. It has a vertex at 0, 0, and goes up on the right and up on the left. So if we're looking for the domain of this function, we're going to read this graph and we're going to work furthest left to furthest right. So in this graph, the furthest left this function goes is actually negative infinity. This arrow tells us that this graph is going to continue left forever and ever. It's never going to stop going left. Well, the largest left value we say is negative infinity. So our left bound is negative infinity. Then the right furthest this function goes is also infinity. So this is going to the right forever as well. Right forever is actually a positive infinity. So our domain is negative infinity to positive infinity. So you may see this quite a few different ways. This is also called all real numbers, so you may actually see it written out. You may also see it with the double barred R symbol, and you can also see it using inequalities, negative infinity, less than x, less than positive infinity. Those are all the same way to write all real numbers as a domain. So now let's talk about range of the parent function absolute value. So range is all of your possible y values, so you're working on the y-axis here, bottom to top. So the lowest this graph goes is actually going to be this vertex, this sharp point right here. So the coordinate here is 0, 0, but because we're talking about range, we want just the y value of 0. So the lowest this function goes is going to be a 0, and it has this straight bracket here because 0 is included. If it's not included, we use a parenthesis. And then we need to see the highest this graph is going to go. So these arrows we are going to use again. So both these arrows say that this graph will continue up forever. Well, up is a positive direction, so we say that it goes up to positive infinity. You could also see this written as inequalities as y greater than or equal to 0. So let's look at another one. So here we have another absolute value graph. This is not the parent function. So let's figure out the domain and range of this absolute value. So again, let's start with domain. So we need to work left to right. So the furthest left, I see another arrow on the left-hand side, which means I'm going left forever. So that means it has to be negative infinity for the domain. And then I see on the right-hand side, there's also an arrow, which means it's going to move right forever, which is positive infinity. So this is that all real numbers situation again. Let's talk about range. So we need to work bottom to top because range is your y values. So furthest down is actually not our vertex this time. Our vertex is actually the top of my graph. So we need to figure out how far down this graph is going to go. Well, this arrow says I'm moving down forever, and this arrow says I'm moving down forever as well. So the smallest number you're actually going to hit is negative infinity. Then the highest y value is this point right here, that's your vertex. So that has a coordinate of 1, 2. But because we're talking about range, I need the y value. So my highest value is a 2 with a closed bracket. You could see this written in inequality notation as y less than or equal to 2. Let's look at one more. Example 3. So here's an absolute value function, but now it's only a piece of it. This actually stops on both left and right. So if we look at the domain of this function, we need to figure out furthest left to furthest right. So the domain furthest left is actually this point right here. So the x value of this point is here on your x-axis. So that's the furthest left my graph is going to go. So let's count. 1, 2, 3, 4, 5, 6. So negative 6 is the furthest left. Now because this has an open circle, that means I need a parenthesis, not a bracket. Now furthest right is this point here. So its x value, again we want x's because we're talking about domain. 1, 2, 3, 4, 5, 6, 7. And because he is a solid circle, a closed circle, we're going to use a bracket. Now let's talk range. So range is your y values. So I want to go bottom to top, smallest to largest. So the smallest point is this vertex here. So I need this guy's y value because we're talking about range, so I want the y value. 1, 2, 3, -4. Because this is just a solid line, we're going to use a bracket. And then I need the highest y value, which is this point again here, but I want its y value because we're talking about range. So I need its y value of a 1. And again, because it's a closed circle, we're going to use a bracket.